You talked a bit about the possibility of a plane being flown into a nuclear power plant. What's the worst case scenario if, say, you get a direct hit on a spent fuel pool? And you talked about time. How much time are you talking about?
Enough time to do all of the things that we need to do to protect the people. Spent fuel pools are really, in our assessment, have come down several levels on this or safety assessment. Spent fuel pools are okay. We know what we will have to do. There is really very low probabilities of any significant hazards to the public from a direct hit on a spent fuel pool. It's just really not there. That doesn't mean that everything is hunky-dory every place. We have systematically analyzed all of these systems. What I can tell you is that there is enough time to protect the people around these plants and the people of this country, and that we know.
What's the technical basis of that? Is it just that it's hard for them to actually catch fire, hard to imagine a leak of the water? I mean, what makes it hard?
Great. It's an excellent question, by the way. Nuclear power reactors don't have mechanisms for quick releases of radioactivity. They're just not there. Small releases of radioactivity, a little bit of radioactive water in a place, yes, but those are not consequential. What we always worried is if the core of the reactor melts and the radioactivity of the core goes to the environment. Okay, what we have found is that the way that these plants were built, operated, and what we call the severe accident mitigation strategies that were put in these power plants in the late 1980s, early 1990s, are very good at mitigating whatever can happen, whether there's a plane crash or somebody throws a bomb. It's the combination of these systems, okay, are so robust that even if worst case things happens, we have plenty of time to protect the people of this country. So what I'm saying flat out is that there are no quick mechanism for significant releases of radioactivity that we have identified. Does that mean that the probability is zero? No, I can't say that, but it is very low. Does it mean that we know everything that we need to know? It doesn't mean that. It means we have analyzed every angle that is most probable, every structure, every system. We have looked at every type of airplane. We have looked at different ways of doing it, and we are convinced, enough for me to stand here and to tell the Congress of the United States that the probability of a significant radioactive release to occur before the time that we have protected the people is very low. And that includes, okay, not only nuclear power plants, it includes all the spent fuel pools, the independent spent fuel pools facilities, it includes dry cask, and it includes transportation of spent fuel. The one transportation, rail transportation cask that we have analyzed. And all in those cases, there is either little release, no release, very little release, but in all cases, there is time to protect the American people. And that's the answer that we needed. That's the answer that we have. And that's what we are clearly, coming out and saying.
Does that mean evacuating people or just getting them under control?
It means both. It means eventually if we have enough time to get things under control. If things we have not foreseen happen, there will be plenty of time for evacuating the people and having our emergency plans in action. And as you heard me said, and this is the reality, is that emergency preparedness has been elevated to a new level. Does that mean that we're not confident of our results? No. We are confident that we're getting good results. But we also realize that we cannot stop there. Therefore, we have taken emergency preparedness to the next level of effectiveness. Yes.
Good.